Hi there, welcome back to our journey learning 6502 assembly on the Apple II. Today we talk about access to files in floppy disks. So we're going to depart a little bit from the book assembly lines that you see here, because this chapter is based on DOS, on the disk operating system. But the environment that we have been using is based on ProDOS, which is a more advanced operating system than DOS. And before we launch into how we access the floppy disk using the disk operating system, I would like to make a brief recap into how we used to store data using 8-bit computers like the Apple IIe. So initially, when the Apple II came out on 1977, there were no floppies. There was no magnetic. There were not magnetic disks being used for media storage in the Apple II. So what was originally used was just cassettes. So there are some input-output jacks in the computer that you can basically save a program as a sequence of sounds, and then you play back those sounds and you can load them back to memory. So by the end of 1977, actually, Apple released the Disk 2 floppy disk drive, and it comes with the disk drive itself and a board that you put inside the computer in one of the slots for extension, and basically that will cause the computer, when it's booting up, at some point to load some code into memory, and that code knows how to talk to the disk drive, and then it will search for a floppy disk like this one on the disk drive, and then it's going to finally load the operating system itself from the floppy disk into memory. And from there, you can actually do things like read your own text files. For instance, it's going to put in memory some basic routines that we can call. So all the other routines that we have used so far, they are actually part of the Apple monitor, which means the firmware that comes with the computer. So it's really, this is stored in microchips inside the computer, and every time you boot it up, they are already there. But the routines that do disk I/O, they are actually not part of the monitor. They not come with the computer. You have to load them from a disk. So the first incarnation was the OS, disk operating system, the Apple DOS. So there were 3 versions of it. 3.1, 3.2, and 3.3, if I'm not mistaken. And at some point there was ProDOS, and ProDOS was an improvement over DOS. It did use more memory, so you needed at least 64K computers, like the Apple IIe has 64K from factory, but that was not the case of the original Apple II. That one needed memory extension to use ProDOS. But yeah, when ProDOS was launched in the 80s, Apple computers typically had at least 64K of memory. That particular computer actually has an extension and has 128 kilobytes. So it's a lot of memory for 1984. But as I said, this chapter on the assembly lines book is talking about DOS, DOS, but we are going to talk about ProDOS. So they are not that different conceptually. So I mentioned that we have routines that are loaded from floppies into the computer's memory. And this is what DOS, this is not ProDOS yet, this is DOS. So DOS loads reserves a certain area for buffers, meaning temporary memory space that is used moving things from disk to memory and vice versa. And then they load in a certain section of memory the main routines. This is really like the core routines of the file system. I'm sorry, of the operating system, the disk operating system. And then we have file manager, which is a higher level interface. This is the one that we use to read and write to files. We have open file, read file, write file, close file, seek in something inside the file, this kind of level. And then we have this RWTS, which are routines for reading and writing tracks and sectors, which are really like the physical organization of data on the surface of a magnetic disk. And of course, the file manager routines actually use the underlying RWTS routines. So this chapter of assembly lines would be about how to call some of the RWTS routines, and then later they explain how you call some of the file manager routines. But I propose to do something a bit different today, because the environment we have been using, Paleotronic's IDE with Merlin, the assembler, and an emulator of the Apple II comes with ProDOS used by default. So you can find online another book called Beneath Apple ProDOS. Actually, there's both Beneath Apple DOS and Beneath Apple ProDOS from the same authors, and this is easily found online. And you see that ProDOS similarly will load to memory different areas with different routines. And they also have, let me show you here. Yes, so they also have a set of routines that really give you very basic access to the disk, and then you can do things like literally turn on or and off the motor that keeps the floppies spinning. You can turn on and off things really at a very low level. And then you have block access, where you read and write physical blocks. And then you have what they call the Machine Language Interface, MLI, and this is what most people will care about. This is really that level where you can open files and read files and write files. And unless you are writing a low-level disk access utility, in which case you really have to become an expert in all things concerning the particular disk operating system version that you are using. Most people will really want to just be able to save some data in files and then read that data later. So we are going to cover that aspect in today's video. So without further ado, let's go and see some code. Okay, so this is going to be a slightly longer code than we are used to. Yeah, we are getting, of course, as we get more proficient with assembly, we start writing longer and more complex programs. So first thing you're going to notice here is that we are putting it not at memory location $600, but at memory location $6000. And that's because our program becomes longer, and on $600 it basically overruns video memory because it becomes too long. But that's all right. I mean, we can put this in the most convenient memory location as long as we are not overwriting anything we care about. So this program we are going to create a new file using ProDOS Machine Language Interface. This file is going to be called ABC, and we are going to also write some text to it. Of course, later there's another program that reads the file. So here, as usual, we have a lot of definitions of memory addresses and whatnot. But let me start a bit at the bottom, and then we come back and revisit some of these things. So the first thing we need to do is to create a file. And by the way, on ProDOS, you can type catalog, or cat for short. And then here you see that we have already 3 files in our operating in our floppy disk, in our virtual floppy disk. So the base directory is /system, and then we have a file called ProDOS of the system type, another called basic.system of the system type, and then a file called test. There's no dot here, but it's a test file called test that is of the type basic. So we don't care about these files. We want to create a new text file. So the thing about creating a new file is you have to call a command to create a file, an MLI command. And there's a bunch of these commands that you can call. And all of them, they have a number of parameters that you have to set. And you can check all this information in that book beneath ProDOS. So you see that this point here on line 38, this is where we put in the accumulator the code for the create file command. And then we put this in a place that's a base address called MLI plus 3 bytes. And then we call a subroutine MLI, and that's where the files get created. So this is quite important that we understand this. So if we check this MLI subroutine here, what we do is we transfer control to ProDOS. We call a subroutine on ProDOS, and then we provide some data here. And this data, which you see, because we have 2 bytes here, so that's byte 1, byte 2, and then the 3rd byte, that's where our data starts. Remember that we were informing an address that was base address MLI plus 3. So that's basically landing us on this data region. So we are providing this data that's going to be read by this ProDOS subroutine. And the ProDOS subroutine will learn from reading whatever is in this area, what is the command being requested and what are the parameters. So we have some new opcodes that we are using here. So this DFB means defined byte. So basically this, we are saying, I want to put in this memory location 1 single byte and with this particular context. It's basically, it has 0 for now, because that's exactly what we do here. We put the command, in this case open, the code for the open command, we put it overriding 0 here. We put on this memory location, which gets called by ProDOS subroutine. And also we have here again a definition of another structure, data structure called params, and this is basically the address. So we're saying I want to put here a byte that is the memory address of params. And if we see params as in parameters, it's here. It's defined as a data sequence of 12 bytes. So we see that we have here the defined byte DFB, we have the DW that gives us the address of something else. And then we have this DS that we can define a sequence of data, and then we say how long it is, and it's going to put this number of bytes. So we're basically allocating here a region of memory that is at the location params and it's 12 bytes long. And also we see that we have another opcode ask that defines a character string. So we provide this with just a string between quotes, and this string gets stored in this memory location. So these are all useful new constructs that we have. So you see that the idea here is that when we call the MLI routine, we provide the address where ProDOS can find all these parameters. And if we take the create file, it needs 7 parameters, so we have to pass the number 7 here, and if we pass a different number, basically we get an error. And then we put this number of parameters as the first entry into our params data structure. Then we put the address where we can find the name of the file to be created, and that's on params +1 and params +2. And this is also new. This basically we are taking a memory address, and here we say I want the low byte, and here I say I want a high byte. So we use 2 bytes to represent memory location, and that gives us 64K addressing, right? Because if I have a single byte, I am limited to 256 values, but if I have 2 bytes, I can go as far as 64K. So that's why we use 2 values for the memory address, 2 bytes for the memory address. And you see that this name is defined down there, and it's basically the length, and this is 11 is the length of this string. And then we have the string itself, and because our base directory is /system, we put the full qualified name /system/abc. Then after the name of the file to be created, we say what are the access privileges. And here, this is sort of a bit mask where you can indicate whether a file can be read by anyone, can be written or not, it's write protected, whether it's executable or not, all these things. So basically C3, it's full permissions, full access. Anyone can read this and write to this file, and it's not executable. So we define the access privileges, and we put this in params +3, and then we say it's of the type text. It could be file basic, could be binary, could be others, but this is a text file. And then again, we use 2 bytes to say what is the length of records in this file. This is not something that we really care about at this point. This is more of an optimization. We can see this later. And then we say that this is a file and not a directory. So it's a title. You can either have files or directories. This is a file. And then we can set creation date and time. We are just setting everything to 0. We don't care about date and time at this point, but you could set it here. Actually, there are other MLI commands that you can query the current date and time to ProDOS. And finally, we put the command ID. We saw this before, and then we just call the machine language interface function. And if we have an error, we are going to have the carry flag set, and in that case, we have in the accumulator the error code. So I basically put here a handy, let me find it, a handy error handling routine, where basically we print the error code and then we print the string error code after that. This helps a lot because if something goes wrong, we can easily see the outcome. And then after this point, the file is created, and then we have the open file command. It's very similar, but has different parameters. It has 3 parameters. We don't have to set the name because it's already set from the previous command. It's the same. We do set some memory address that acts as a buffer from so we can open this file, and then we just open it. And finally, we have, well, not finally, because there's something that happens after this, but we have then the write file subroutine. Again, it's same thing, but now we have 4 parameters. Name is already set, buffer is already set. When you open the file, it actually gets a reference number, because you can have multiple files open and then you need to know the reference number of each one of them. It's like a file ID, and this reference number is put in a certain place in the param structure so you can read it from there. And we actually needed to retrieve it where it was put by the open command and put in a different place where it's needed for the write command. It's this ref thing that we are storing here. So we have here a memory location where we basically are storing this reference that comes from the open file. Then after setting the reference, we actually point to the data that we want to write, and in this case we want to write a string hello. This is the content of our should be the content of our file. Here we say again with 2 bytes how large is the content that we are writing, and usually we're gonna write more than 5 bytes, right? But hello only has 5 bytes, and that's what we're writing. And then I set the proper command code and do what you are already familiar with. And by the way, I think I deleted something from here while I was searching for the handle error, so I just made sure that everything is fine again. So after we have written hello, we have to close the file. Close the file only has 1 parameter, and it's the reference number. And then we do all the stuff that you are already familiar with by now. And that's it. I mean, there's some parts of the program where we print the error message, and also at the end we print a final message stating that we have written the file successfully, just to confirm that everything went well. But I don't have to really to go and go through that code with you, because it should be already familiar. And you see that here we are defining the values of all these MLI commands, and also some monitor routines that we already know, and some also other some constants that we care about. So let's now run this and see what happens. So created file ABC, let's check whether this is true. Yeah, you see here we have file ABC of type text, no date because we just set zeros for the date. Oh, it worked. What happens if I try to run it again now? We have error code 47. If we check the beneath ProDOS manual, for possible errors when we're trying to create a file, error 47 means the file already exists. We already have a file with this name, which of course is the case. So if I delete the file and I run the program again, then it works again. So you can see this is how we create and write to a file. So now I would like to switch gears and show you a very similar program that reads this file. So it's slightly shorter. You see that we have some different commands here. Open and close are the same. We do not need create file. We do not need write. So I will not explain open file nor close because you already know this. We can check only the read file part. And read file, it's a command that takes 4 arguments. We already have name and buffer set from the previous open command. So all we need to do is put this familiar stuff, but instead of now providing a place where we have the content to be written, we provide a buffer where we should write the contents of the file to. So this read command is going to read from this, can put in this in memory in this buffer that you point. And here I have created a buffer of 512 bytes. We don't need that, we only need 5, right? So we also say, okay, we want to read 5 bytes from the file. So we open the file, we read the first 5 bytes, which should contain hello. And basically at the end we print this out to the console using techniques that you are already familiar with. So I will not explain much more about this command, about this program, because it's very similar to the previous one, but with one different command. So let's see this in practice. I'm gonna assemble. And I am going to execute it. Yes, hello. You see, this is reading the contents of this file and is, yeah, we are printing to the screen. So one interesting test here is what happens if we delete the file and we try to run the program again. Sometimes this execute for some reason truncates the command, and then we get this syntax error, but we just run exec again. It's some limitation of the environment. It's nothing to worry about. Now we have error code 46, and I'm pretty sure that if I head to the beneath ProDOS book, I will find that this is, I'm trying to open a file that does not exist. So that concludes our episode on doing disk I/O. Now you know how to create files, write to files, and read files under ProDOS using the machine language interface. If you happen to program for DOS instead of ProDOS, you cannot use this MLI. This is specific to ProDOS, but you have very similar constructs that are used in DOS, and you can find the book Beneath DOS, which basically will explain how to do all these things. And if you can follow the examples here, I'm pretty sure it's going to be easy. So I hope you have enjoyed this episode, and I would love to see you for our next episode. So see you.